Hello, I have been asked to explain by someone the interior angles of different dice. Uh, I explained how, the internal angle, if cutting on a miter saw to make a large, say, 20-sided dice, is about 21 degrees. So they asked me how I found that out, and so I thought I'd make this video explaining it because it was a little too much to type out in a comment. So, for example, when looking at a dice side, particularly a platonic solid. This only works with platonic solids. So, for example, a d4, d6, d8, d12, and d20 are platonic solids. Other dice, you will see that the sides meet up at different angles around the whole dice, giving them a non-kind of uniform shape. With those, you would have to look at each angle individually, but with platonic solids, you can easily look up the internal angle. So, for instance, let's just do a cube because a cube is kind of easier. So a d6. So for a d6, you know that you would need your wooden sides to meet up at kind of this right angle, right? And you would know that you need to connect them right here. So if I draw this a little bit bigger and shift my angle so I don't draw terribly, you'll see that if you find this angle, which you can look up online because all these geometric principles are listed online, and you want to find out, either this angle or this angle to cut at, what you can kind of do is just split this in half, so you're only looking at one piece. Now, if you split this in half, you see that this line goes directly through the angle that we looked up. So the angle in this half would be theta over 2. So if we take off this half and kind of shift it over here, right, we know this angle. We know this is theta over 2. Now this angle and this angle are actually going to be the same. So we know that this is also theta over 2. So this means that if you're adjusting your saw, if you're looking from the horizontal, it'd be theta over 2. If you're looking from the vertical, then what you can actually do is let's call this alpha, right, A. We know that this forms a right angle, right? This line and the base of our wood will form a right angle. So a right angle is 90 degrees, would be equal to A plus theta over 2. So that means that alpha would have to be equal to 90 minus theta over 2. So this tells us either if you're going from the horizontal, your angle that you would need would be theta over 2. If you're going from the vertical, it would have to be 90 minus theta over 2. So, for example, the internal angle of a cube, or d6, would be 90 degrees. 90 degrees divided by 2 would be 45. 90 minus 45 is also 45. So you need to cut it at a 45-degree angle, and that's how we meet, wood sides at a 90-degree angle. But, say on a icosahedron, d20, that has an internal angle of 138.19 degrees. Now, 138.19 divided by 2, that would be from the horizontal, and that's about, what is that, 65, 60, 69? So that's about 69, I believe. Yes. So that's about 69 degrees from the horizontal. But if you were to do 90 minus that, that would be about 21 degrees from the horizontal. About. If you want to get more exact, you can actually just do this math. So you could do that after looking up the internal angle of different platonic solids, and from this easily find out either the horizontal angle or the angle from the vertical that you would need to cut your wood at. And I used this strategy to make a very large d20 out of wood, and it rolls pretty well, and I've nailed every side and did custom art for it, and so using that strategy I was able to actually create this on just with a miter saw and some nails and wood glue, and then everything else is just for show. So now knowing that, you can look up your own angles, and at the end of this I'll put a chart that shows all the platonic solid angles and the angles from the horizontal and vertical. Alright, hope you learned something.